Hello people, good morning, good afternoon again, whatever time it is. I hope you're keeping fine. Some of you did excellent work last lesson with solving simultaneous equations and you're ready to move on to the final bit, which is the trickiest bit, which possibly is the kind of questions that you can expect to see in your GCSE exam. Those of you that didn't do any work last lesson, those of you that still haven't got your heads around solving simultaneous equations by elimination, you need to go back, check out the previous two videos and practice some of those before doing this, okay? Because this is the final step. This is the trickiest bit. So here we go. Solving simultaneous equations by elimination. I'm going to go through two examples and hopefully that would be enough for you to get working. So here I've got my first set of simultaneous equations. 2x plus 3y equals 9 and 5x plus 4y equals 19. Now remember, when we solve simultaneous equations by elimination, we want to have the same amount of x's or y's in both equations. And typically what we did before is that we would multiply one equation in order to have the same amount of x's or y's. That was step number one. However, if you look at this equation here, if I want to have the same amount of x's or y's, it is not clear what is it that I have to multiply one equation or the other. Because if I multiply that one, it doesn't work. If I multiply that one by 2, I don't get the same amount of x's or y's, or 3 or 4, or anything like that. So in these cases, you have to change both equations. You're going to multiply both equations by some number, and it doesn't have to be the same number for both. One equation could be 3, the other one could be 5, okay? So, first of all, you're going to decide which variable do you want to get rid of first, which variable you want to eliminate. Me, myself, personally, this time round, I'm going to choose x. I want to eliminate the x variable first. And in order to do that, I want to have the same amount of x's or y's. Sorry, the same amount of x's. If I look here, I've got 2x. And here, I've got 5x. So, the numbers 2 and 5, I need to think about what is the lowest common multiple of 2 and 5. And the lowest common multiple of 2 and 5 is 10. So, that means I'm going to end up with 10x in each equation. How do I get from 2x to 10x? Multiply times 5. So I am going to multiply everything in the first equation by 5. Everything. So, if I multiply the first equation by 5, I get 10x plus 15y equals 45. Sorry, there's a bit of a reflection there, but I'll hopefully can see it a little bit better. 10x plus 15y equals 45. Now, with the second equation, I also want to have 10x. How do I get from 5 to 10? I need to multiply by 2. So if I multiply the whole equation, remember, by 2, I get 10x plus 8y equals 19 times 2, 38. Alright, so now we're back to the equations that we knew how to solve before. I've got the same amount of x. Now I need to decide, am I going to add or am I going to subtract one equation from the other? How did we figure out whether to add or subtract? That's right. You look at the signs of the variable that you've got the same amount of. So I've got the same amount of x's. The signs on the x's are equal. Doesn't matter whether they are positive or negative, so long as they are equal. And because they are equal, when the signs are equal, we subtract it. So I'm going to take away one equation from the other. Remember, you could change the order of the equations. Here, I don't need to. It just makes life easier avoiding negative signs. Anyway, we're going to take away 10x, take away 10x, that's 0. 15y, take away 8y is 7y. And 45, take away 38, the answer is 7. So if 7y equals 7, then y must be 7 divided by 7, which is 1. We're not finished yet. We found y. We also need to find x. And remember, how did we do that? We took that value and we substituted it into one of the first two equations. Which one? Doesn't matter. Whichever one you think is going to be easier. I am going to substitute it into the first one because the numbers are smaller. So if I take this and substitute it into here, 2x is 2x plus 3y, but y is 1. So 3y, 3 times 1 is 3, equals 9. Now I need to solve this equation here. 3, when I move it to the other side, it changes sign, goes subtracting, so 2x equals 6, therefore x equals 3. And I found y, I found x, I finished. I can check that my answers are correct by substituting the two values into both equations. 2 times 3 is 6, plus 3 times 1 is 3, 6 plus 3 is 9, that's correct. 5 times 3 is 15, plus 4 times 1, which is 4, 15 plus 4 is 19. I am correct. Well done, me. What about you? Okay. Now we are going to have a look at this other equation here. Another example, very much the same thing. X's and y's. This time I am going to get rid of the y's. I'm going to change it around, mix it up. If I want to get rid of the y's, I've got a 3 and a 4. So remember, I need to think about the lowest common multiple of 3 and 4. And the lowest common multiple of 3 and 4 is 12. So I want to have 12y in each equation. How do I get from 3 to 12? Multiply times 4. So multiply the whole first equation by 4. So I get 16x plus 12y equals 15 times 4, 60, equals 60. And the second equation, again, I want to have 12y. How do I get from 4 to 12? Multiply times 3. So multiply the whole second equation times 3. So I get 15x minus 12y equals 33. Now I've got the same amount of y's in both equations. Good. Now I need to decide, am I going to add or am I going to take away the two equations? I need to look at the signs on the y's, and the signs are different. And when the signs were different, we added the two equations. So if I add them together, 16x plus 15x, well, that's 31x. Positive 12y, add negative 12y, that's 0. And 60 plus 33 is going to be 93. So 31x equals 93. X is going to be 93 divided by 31. No problem. The answer is 3. X is 3. Have I finished? Correct. I need to find y. So I'm going to take my x and I'm going to substitute it into any of the two first equations. This time I'm going to substitute it into the second one because I feel like it. It doesn't really make a difference. X is 3. 5 times 3 is 15 minus 4y equals 11. Okay, well, that 50, because I need to leave the y's by themselves, I take the 15 to the other side. And what happens when 15 goes to the other side? It goes subtracting. It's a positive 15, so it goes subtracting. Careful here, I've got a minus. So minus 4y equals 11 take away 15. 11 take away 15 is minus 4. So y equals, that negative 4 is multiplying the y. It's multiplying. So when it goes to the other side, it goes dividing. So y is going to be negative 4 divided by negative 4. No problem. A minus divided by a minus is a plus. And 4 divided by 4 is 1. So y is 1. So now I've finished. I found that x equals 3, y equals 1. How can I be sure my answers are correct? Substitute them into the original two equations. X is 3. 4 times 3 is 12. 12 plus 3 times 1, which is 3. 12 plus 3 is 15. It works. On the second one, 5 times 3 is 15. Y is 1. 4 times 1 is 4. 15 take away 4 is 11. I've got it fine, I've got it right, I've got it sorted. I can change both equations. I can figure out whether I need to add or subtract the two equations and substitute to find x and y. Alright, this completes the elimination method of solving simultaneous equations. There's another method that we'll look in the future, but for now you need to practice this. Watch the videos many times as you need, take notes, walk through the examples as I've gone along, and I'm here. Message me if you've got any questions. I believe in you, but do not attempt these until you feel comfortable and you've practiced the previous two cases. All right, excellent. I've got every faith in you. I know you're going to do well. Message me, get in touch if you need any help, and I'll see you soon. Take care. Bye.